Hey there. So this is going to be a video about the solid design principles. Now there's a lot of different programming practices and a lot of different programming principles. We're going to be talking about this specific one, and this is what we're going to be using kind of in the back of our mind whenever we look at designing a new feature or designing a new function. So let's talk about exactly what these solid design principles are. So SOLID is an acronym that stands for single responsibility, the open-closed principle, the Liskov substitution principle, which that one is, I think, is the weirdest one, interface segregation, and dependency inversion. So let's talk about what each of these things means. Single responsibility means that whenever you're writing a script or a function, or in Unity's case, making a game object, you want to have that game object have a responsibility. Now, that doesn't mean that it only does one thing, but you want to have it be kind of separated out into different functions. Anything that controls the animation shouldn't be controlling the movement, which shouldn't be controlling something else, like, health. You want those things to be separate. Now, those separate things can all come together to make one bigger entity, like a player or an enemy, but you want to have it be separated into as small components as you possibly can, so that way those components can kind of be broken off and interchanged with each other like Lego bricks. The open-close principle, what this means is you want all of the functions that you make, or all of the game objects or scripts that you write, to be open, to be extended, but closed to be modified. You don't want anything to be able to be modified by something that you didn't necessarily expect it to be. So that way you're kind of keeping down any unexpected behavior from scripts. But you want to have them open to be modified. For example, this can be seen in kind of some main programming principles where if you have an object, let's say, an animal, a cat is an animal, a dog is an animal, a chimpanzee is an animal. So you want to have this broad overarching idea that is then separated into smaller ideas that extend that, and then further extending, like cats, you can have a house cat, you can have a big cat. House cats, you can have 85 million different breeds of house cats, and big cats, there's however many different kind of big cats. But that way you're extending it, but you're not modifying what it means to be a cat. A house cat is still a cat. It's not modifying that main idea, if that makes any sense. The Liskov substitution principle means that when you're doing that extension, any one of those classes or ideas or functions that extend from the main one should be able to substitute back in for the main one. So if I said, go get me a cat, and you brought me a mountain lion, well, you brought me a cat. If I said, get me a cat, and you brought me a chimpanzee, well, then the Liskov substitution principle isn't satisfied. We're not able to substitute any one of those base classes back in for the main one, if that makes any sense. Interface segregation says that whenever you're having an interface, you should have your interfaces segregated into individual ideas or individual functions. So when we're going to be talking about this, one way that this can kind of be directly translated into Unity is the way that we actually build interfaces. This is something that we'll be talking about here, kind of keeping. And this goes along with that single responsibility. You don't want one thing, one interface, to be controlling everything. You want that one interface to have sub-interfaces that come together to make the big one. And the last one is dependency inversion. Dependency inversion says that this is kind of like the Liskov substitution principle, but it's more focused on how functions work. Dependency inversion says that you should be able to depend only on abstract versions of things and not concrete versions of things. So what that means is if I have a function, like say for an ability system, where I want that ability to work, I want to make sure that I'm making the ability function as abstract as I can, and then anything that's concrete can come off of that, so that the ability system itself isn't very concrete. We're kind of inverting that dependency so that we don't need a very rigid connection, if that makes any sense. So if you're new to programming, this solid term is something that you might end up seeing in a lot of places. And it's my experience that people who write about programming or talk about it, don't always stop to explain what solid means. They'll just say solid or agile and then kind of move on without actually explaining what those terms mean for somebody who isn't necessarily into all the jargon. So solid is kind of a mental framework to keep in your head when you're designing things, so that you want to try to keep all of these principles satisfied, so that what you're making is extendable, kind of lightweight. You're making these kind of not rigid connections between things. I like to think of it more like Lego bricks. You're going to make these components that can snap together, but they can also come apart when you need them to. So you're not kind of welding the two Lego bricks together. You're not using crazy glue on it. Instead, you're just snapping them together so that when you need them to not be together, they cannot be together. So this is kind of a weird one. This is more of like an actual lesson. So I hope you still enjoyed the video, and yeah, have yourselves a great day. All right, thanks very much for watching. I hope you learned something. Feel free to hit the like and subscribe buttons down there if you did learn something. You can share this to your social media platform if you think somebody you know might want to learn it. You can click the bell icon. Just go nuts on those buttons down there. There's so many buttons. Why not try pushing them all? Except for maybe dislike. Maybe leave that one alone. If you have any questions or comments or concerns, feel free to leave them in the comments down below. If you open up the description, you can see that I have provided links to my Patreon, where if you want to chuck in $1 to make sure these videos keep coming, you sure can. My Discord channel, where not just me, but other people are chatting every day, kind of helping people out who are trying to learn this whole trade. You can find my itch.io page, where I have some assets and some general frameworks. And yeah, there's also some kind of general use links down there, so feel free to check out that description. Otherwise, I hope everybody out there has themselves a wonderful day.